right, model, and we got this output. We examined the outputs also in terms of measurement model and the inner model or the structural model. Then we found that everything to be in order. And let us see the reports, right? So you see here in the report, you have various options. You have a graphical, which is what is given here. And you have the final results, which are given in terms of path coefficients, indirect effect, total effect, because you have mediation, etc. So we have all the reports here also. Then quality criteria, this is important for your measurement model. Reports your construct reliability, discriminant variety, VIF factor, model fit. So this is mostly used for your measurement model, as well as you can use some of it from the for the this one for your structural model also validity. But one thing you will note that if you click on path coefficient, it gives only the beta values. That means the path coefficients it gives. It doesn't give you the p values or the confidence intervals. So for that, we will have to run the bootstrap. Before that, what we can do, we can copy there are two options. You can export it to Excel. If you see at the top in the toolbar, you have this Excel option, HTML option. So you can export the data, the report into an Excel file. If you click on that, it will ask you whether you want to export or not. If you say export, then it will ask you where to save it. But my suggestion, or generally it is suggested, that you should generally copy it to Excel. This option you should take. Now you see here, you have the zoom option, using which you can zoom in or zoom out the results that are visible. So let us, you can also copy to R, because R also uses SEMs. I think Ritesh will be covering RSEM tomorrow, isn't it, Ritesh? Yeah. So in that case, you can export it to R, and he can import it in the R software there. So
we will cover PLS on R tomorrow.
Yeah, PLS on R. You can. So this is the option. So we copy it to Excel. Open an Excel file. Can open a blank file. Let me. I think you are not able to see this, correct?
Yes, sir.
Yeah, so I have to share this. Okay, fine. So stop share and share the Excel file. Right? So this is our Excel file. So it's always better to copy in Excel, and from here you can take it to your Word file instead of directly taking it from the exported Excel workbook in the export option. It's always better to do it here. Do some whatever modification you want to do in the Excel file, then copy paste it in the Word instead of directly copy pasting into Word or taking it to the through the export option. This is the best one practically, so you can do that. So you can take it, and let us say you want to give the path coefficients here. You can create this sheet as path coefficients, and you can paste the right. So path coefficients are available. So you see, so CUSL is your this one is your target variable, and the path coefficient, and this one is your mediating node, CUSA. So competence to CUSA, it is 0.162, whereas from CUSA SU to this one customer loyalty, it's 0.009. CUSA to CUSL is sorry, competence to customer loyalty, it is 0.009, hardly any. CUSA to customer loyalty is pretty high, 0.505. Customer loyalty, of course, is a target variable. Don't get it. And then from likability to the mediating node, you get 0.424, whereas for customer loyalty, it is good 0.342. So here you can get it. Otherwise, what you can do, you can also have an option. Here, let me go to this one. Let me share it again. New share, and are able to see the PLS screen?
Yes, sir.
Yeah. So you can always, you can have other options also. You can have list option, where in this one I can get it again, copy it to Excel, and go to new share, and then come back to Excel. Where is this Excel file?
So you don't show the Excel file because
Yeah.
it's simple.
Yeah.
Everybody can copy and paste. I
Yeah,
think your
correct.
PLS screen is visible and that is enough for us.
No, this is okay. This Excel is visible now.
No, it's visible, clear,
Yeah.
loud and
So
clear.
you can copy paste here. So the same thing is available in the list format also. So you can directly make some whatever modification you want to do. For example, you want to draw this one on the borders, and whatever changes you want to make, making it bold, all those things you can do, and then take it. But I am not going to do that because we will be taking, we have to have the p values also. That we will get it from Bootstrap. Anyway, so that being so, let me go to this one. There. Yeah. So this is how you copy paste the path coefficient. Now, if you see let us go to the quality criteria. Under that, R square. You got the R square, adjusted R square. Both of them are available. So you can copy paste it here, and you can copy paste it to Excel. We'll show it later on. I will copy paste into Excel. Another sheet, R square.
Sir, can we revise the all the qualities criteria with their benchmarking value so that we will get revised again today? Threshold value, which are important value, just revise it.
Okay, so that also we can do, not a problem. So
no, I don't think so. I don't agree with the suggestion. I'm sorry to say this, because these values, no, this is theory. You can read whether it is good or not. But right now we are focusing on how to operate Smartpls. I'm sorry to say this, but our focus should be on how to operate and how to get different values from Smartpls. Whether that value is significant or not, that's a small literature. If you refer it in literature, you will get it. I'm sorry, but because we are running out of time, we will not be able to stretch on this topic. So
fine.
please
So,
go
Okay,
ahead.
sir, no issue. I thought that.
I
no
hope
issue.
you understand. Sorry.
Right. So like that, you can what do you call, copy paste into Excel, right? So let me share the Smartpls screen again. Yeah. So you are able to see the Smartpls screen.
Yes,
So
sir.
R square. So now you come to F squared, which is the effect size. Again, you can have it in this matrix form. You can copy paste it. So it gives you the effect size for each construct to the target variable, right? So hardly you have any effect on the CUSA, but you have got from CUSA to CSL. Effect size is pretty good, 0.41. And for likability to CUSA, it's say it's not bad, 0.115, and to CSL also the medium range 0.135. So for likability, of course, like to like is not there. So this is with respect to the effect size or the F square, and more importantly, let us see the reliability and validity. So this reliability and or the measurement module, let me reduce the zoom so that you can see the whole everything. Yeah. So just a moment. Yeah, there, slightly less. Yeah. So now you see this is the Cronbach alpha. This is your composite reliability A, composite reliability C, and if you see this composite reliability A is in between Cronbach alpha and rho C, and this all the values of AV is more than 0.5. That means it is explaining more than 50% of the variance, and all the values are above 0.5. Sorry, 0.7. So this reliability is also good, and this is also good. And to confirm that all these things are in green. Had it been not meeting the criteria, let's say if it was less than 0.5, then it would have turned red. From there also you can check. So that is, again, you can copy paste it to the Excel or export it to Excel. Then similarly, you can have a bar chart also is available. You don't need it there, in fact. So, so this is with respect to the measurement model. So whatever requirement is there for measurement model, you can report it from here, copy paste it to Excel, and then again from there to Word file. Now where comes the reliability, validity. Now validity, you have discriminant validity. Discriminant validity, you have STMT criteria. You can see in the list. You see, all the STMT values are less than 0.9 or 0.85 as it is required. So we can say that the discriminant validity is also achieved. And if you see the Fornell-Larker's criteria, if you see all the values in the diagonals are more than that which are below that or which are in the row, right? So all these are more than. So the squared value of the reliability, square root of the AVAR is more than of the correlations of the other construct. So that also satisfies the Fornell-Larker's criteria. But one thing is that nowadays Fornell-Larker's criteria is not in favor. People say insist on seeing the HTMT. So that is more prevalent, and that has to be reported. If it is not giving correct result, then you will have to check the model. You cannot say that my Fornell-Larker values are okay, so the discriminant validity is okay. You cannot do that. So you can see the literature why it is so. I have already uploaded it. You can see that. So anyway, so that is with respect to discriminant validity. And then for collinearity options, you can see for the measurement model, you have all these values are less than 3. So if it is less than 3 or less than 5, it's you can say that the collinearity issues are not there. And this is for the outer model, and for the inner model also, you have all the collinearity values less than 3. So there is no collinearity issues in our model. So that is with respect to the validating our model. So only one thing is left, that is our p-values. That means whether it is significant or not, whether the paths are significant or not, that is one thing is left. And apart from that, the mediation part, right? So we have to see the mediation effects also. So for doing that, we have already saved it. If you go back and we have to do bootstrap procedure to find out the mediation and also the p-values. So simple, instead of PLSM, you click on bootstrapping procedure, and let us take all these which are there as default and make the necessary changes if you like. Normally we don't do the changes. Start. For instance, instead of two-tail, if you have from literature, you know that there will only be one-sided, that is increase only, you have to check, then you can make it one-tailed and accordingly interpret. But we don't make any changes. PLS setup, see standardized path and default value, bootstrapping, 5000 we are going to run the times we are going to run, percentile bootstrap method, and two-tail test, 0.05 significance level. Again, seeding is fixed seeding, and then we click on calculate. Take a couple of minutes, that's all. Not even that. Right. So now our bootstrap results are available. We can of course save this. And you can give a name, bootstrap, BT is given already. We can remove this. 2023, save it or create, it will be created in our project window. And then again, if you want to see the outer model, loadings and t values or loadings and p values, whichever you want, p values 0.00 all if them are significant and more than 0.708. And if you want to see the t values, you can choose that also. And you can see all the t values are greater than 1.96, which is required at 0.05 level, right? So that means all these are significant, and also the values, as you see, are more than that. And if you see the in the inner model, p values instead of p values, you can also ask for path coefficient and p values. Now you can see that the p values are given in the bracket. So this competency to customer loyalty is not significant, more than 0.05. Whereas to the mediating variable or the mediator, it is significant, 0.012. And then, of course, this is also significant, less than 0.05. And this is again, you can see, you can move a little bit down. And CUSA to this one, significant. And this one, likability to customer loyalty, this is also significant. You can move a little bit down, change it, so that you will have some space to see.
Sir, in my model, that inner model is not showing. Can I share the screen?
No, you see inner model, you have got the drop-down list. Drop-down list you are seeing?
But in my PLS screen, I can see inner model. Okay.
Yeah, the drop-down list just beside that.
But in that p value is not coming.
No. If you click on that, you share the screen now. It's showing.
Yeah, I'm. You have to stop now. Otherwise, I
have to stop.
Maybe through this we can clear the doubt of others also. I think this is the graphical output of my model.
Yeah.
And now here inner model is coming, but in inner model there is no p value option. Here is the outer model.
So have you done the bootstrap?
No.
Have you done bootstrap?
No, no.
Have
How
you-
to do that bootstrap?
Go back.
Back.
Then again, double click on the model. Yeah, yeah.
This.
Go. Double click. Yeah, calculate. Bootstrap.
5,000. Okay.
Click on calculate.
Now it will come.
Yeah, now it will come.
Now, where I have to see it, back.
In the inner model, in the canvas, near the canvas, above the figure.
Wait. I think this is BT.
Yeah,
Above the figure,
yeah,
inner model, P values.
Yeah.
Now it is coming. Thanks a lot, sir.
yeah.
So that others' doubt is also solved. Thanks.
Very good.
You
So
can share the screen now.
now I just you stop. I share. Let me share.
I have given you the power.
Okay, fine. So let me share. Yeah. Are
Thanks
you
a
able to
lot.
see the screen?
Yes, sir.
Very good. So you see, so the values are there. So this competence, this one is not significant, whereas all other values are significant. And if you see the in the outer models, outer weights and values, instead of that we can take loadings, outer loadings and p values, right? So that outer loadings and p values, all these are significant, all these are more than 0.708, right? So you can move it a little bit so that you can see the values, right? And here also I can provide, right? कर दिया, इधर ले गया इनको.
Done, sir. I am also doing that. I have done the whole model. Easy.
So you can
Easier than Amos. Very easier than Amos.
Yeah, it's very in the same thing. You can do everything. Every result will be out. I will show you the model mediation also here itself. I just have it. So this is all these things are available. So you from the figure you can
The
see.
last 1 hour remaining.
It doesn't matter. Half an hour I will finish off everything. Don't worry. So now if you see, now let us go to the result on the left panel. If you see the path coefficient, right? Now in path coefficient, you see, as we had visualized there, are you able to see the path coefficient?
Yes, sir.
Yeah.
On your screen, yes.
Yeah.
Yes.
So except for this competence to customer loyalty, which is given in as a 0.806 greater than 0.05, all p values are significant. All are in green and all are less than 0.05. Correct? And if you see the t statistics, all the t statistics except for this comp to CUSL is also more than 1.96. So in fact, we should see this when we are doing the bootstrapping. The t statistics is more relevant than p values, and then so this is also significant. And this is here. These are the values of the beta coefficients. The original sample means. This is your sample means for bootstrapping. This is the standard deviations, and you see there is small variation between this and this. So especially for the competence, which is not significant, even the mean value, original mean value. If you see the confidence interval, there also you can see if you see except for this one, except for this value, all the other values have this sample mean, or you can also see the original means. Both of them are included within this 2.5 and 97.5% confidence levels, which correspond to 95% confidence limit. So that also shows that the results are significant. And if you see the bias corrected, Bias correction is taken when there is the difference between the original mean, which is the point estimate, and the sample mean, which is the mean of all the 5,000 samples which I have taken. Then all of them are almost same, except for this customer loyalty.
So
Otherwise,
in multiple papers I have seen they mention only bias corrected bootstrap confidence interval. They write it BCBCI. Bias corrected bootstrap
bias
interval.
corrected confidence interval. It
They don't
happens
report
that-
only confidence
No, no,
interval.
The thing is that when you should use bias corrected, when you should use confidence interval.
Yes,
That is
sir.
the question. So
What
if
is
the
the
sample
question?
size is small, then you use bias corrected because there will be appreciable difference between the original mean and the sample mean. But if the sample size is large, central limit theory, all this will converge. So there is not hardly any bias will be noticed in your sample of 600 and something. You won't get any bias. So no need to report that. You can report that, no harm, but it will come as same as the confidence interval.
Got it, sir. Got it.
So that is with respect to that. And then let us come to the our mediation, right? Mediation results from here itself. Don't have to go anywhere, right? So mediation results. Now I have also shared the this one literature on that, and I just given an introduction that we need to see only the mediation part. That's all. We don't have to give see the sequential mediation from this, whether this from X to M is significant or not, from M to X is significant or not, from X to Y significant or not, and then conclude that there is a mediation, partial mediation, full mediation. Nothing doing. There is nothing called partial and full mediation in case of PLSM. There is either a mediation or there is no. And there can be a
Sir,
mediation.
can you
no
repeat that
direct
because
effect.
it will help me in my next review. They are asking for strength of mediation. So don't we require to report a partial or full?
Again, strength of mediation. If you
Partial,
are
full.
putting on AMS or something, you can use VAF factor, right? That you can find it from what you call total effect. This
No.
indirect effect.
Don't we have to report
divided by
VAF in
total.
PLS?
So if total indirect effects, you can get it from here, and this one indirect effect.
If we report a VAF variance accounted for by mentioning indirect effect divided by total effect in
so that is
PLS,
not needed
not needed.
for our PLS. Only
Okay.
the effect size will give you the value of the effect. From there itself, we conclude that the question of this VAF for different paths and all.
So when
and
you check effect
calculating
size,
doesn't
when you
work
check
here
effect size-
because it only shows whether there is a mediation or not. If you want to compare the strength of the effect size, F square, right? Effect size, and then from there itself you got the
so
pi
from
F
where to
square.
access F square?
That is F square means in this case path coefficient. Just see the path coefficient, and from there itself you can. First of all, you see which of the paths are what you call significant. So as far as from special indirect effect, this one from here you see both paths are significant. Correct? Both the mediation paths are significant. Special indirect effect gives only for the mediation path. Correct? Had it been moderation also there, then it will give also for interaction effect, which is the moderation. Now from here, first you find out whether which paths are significant. Now these two paths are significant. Once we have found out that both are significant, which is more say contributing or more important, you can find it from the path coefficient. Compare the path coefficient from this one. These two come from COMP to CUSL, COMP to CUSL. The value is 0.009, and from likability to this one it is likability it is 0.342. So no price for guessing which one is more important, which is more mediating. It is the.
So where we can check F square value in this list, F square.
But only one caveat I would like to tell you, Ritesh, that our reviewers still have the old what you call notion of finding out using the VAF factor. So please give both. Let them point out that you don't need VAF. If they say no, VAF is okay, that's fine, okay, needed, then give it. Because always reviewer is the boss, and boss is always right.
Yes.
Right.
So my question is, in which button we can find F square effect size?
F square is the path coefficient for mediation, right? It is indicated by the path coefficient in the mediation, and the point is that first thing you have to find out the reliability of the in fact not even the p value. You have to see the t statistics. T statistics more than 1.96, but then old school always will see the p values. So any case, if it is there, that will also be there. So both the things you report the this one sample mean, and then the t statistics and the p value. All three you report, and then you say that this is significant. Once it is significant, I am going to see the size of the effect through the path coefficient, where you can find out from here. You can see that the path coefficient for the mediation part. From the mediation from likability and competence. These are the two which were significant. Which one is competence to see yourself? Anyway, this was not significant. So this was not significant. So in any case, it was not significant. So there is no question of it's a mediation. So only thing remaining is customer. So likability to customer loyalty. So that is the only part. No question of comparing it with other, right? So there is an option also if you want to compare. Let me show that also. Here there is an option called compare. You see here at the top, the toolbar.
Yes, sir.
Toolbar. After you see HTML create data file, you have compare.
Yes, sir.
Click on that, then it will ask which one to compare. So there is you want to compare the bootstrapping result with the PLSM result. Let us say now there is only one result, so there is no. So suppose you had some other result also, some other option also. For example, you had two models. Both of them, these are significant. Then in that case, you could have used this to compare the two results. Here you have to synchronize it, and then there is an option called synchronize. Yeah. So and it's already synchronized, I think. And then you can select the folder which you want. If you click on select, if you want to compare something on both the screen, let us say you want to compare the path coefficient.
We can also put moderator in the same model here. Just for example, moderator.
Yeah, moderator, I will put next. I will do that. In the beginning itself, we could have put the moderator and got it in the same one click.
As last 1 hour is remaining, we need to cover moderator.
Okay, so let me do that. So here also you can select path coefficient. It will be the same. In fact, it won't be path coefficient. It will be the same. So anyway, so let me move on to the moderation. Okay. Moderation. So we go back. Or let it be here itself. No, we have to draw the moderator. Bring on the moderator. Open the diagram. Right. So moderator is your switch in this case, right? So what is now you see the when you click here at the bottom, you get all some of the descriptive statistics also, minimum, max, mean, median, etc. for the indicator variable that you have given. Anyway, that is beside point. So you can do it for individual items also as moderator, or you can have say, I think this switch 4 is categorical. That's why they had given it only cut for scale of 1 to 4. Anyway, so I am assuming that only 1, 2, 3 are the switching cost, and this is, you draw it here, bring it to the canvas, make it switch or switching cost, whatever name you want. A switch, let us put it as switch, and change the orientation of the indicator variable to give us some space. Click on this, click on maybe down arrow, yeah. And then for moderator, you have to click on moderating effect, and then select, click on select, click on this latent variable, and
so my moderating effect button is not highlighting. Now it is. Now it is.
okay. Doesn't matter. It doesn't make a difference. You can simply, once you have done this, you can simply click on connect, and then draw a line from here to the path which you want to moderate, right? So let us say we want to see the moderation effect on the path between likability and customer loyalty. You can have right. So you see the dotted path. So that shows the moderating path. You can have more than one moderation also on more than one path. For example, you can have this moderation on this path also, on this path also, right? So depending upon your conceptual model, you can draw the moderation on any path, whichever path you want to have. So this path also, if you like, you can have the moderation. So it doesn't matter which one you want to have. Let us say you want to have it on this path also, right? So, and let us say you have another moderator here, switch 4, and you want to see the moderator on the moderator, right? So let us say this is a single, this one. You want to see the moderation effect of this on this. That means this is moderating the moderating path. This type of effect also can be seen, right? So in fact, Professor Lincoln says that you can this software can handle up to 20 levels of moderations, right? So we don't want that. So anyway, just for theoretical this one, I will remove these things. I will remove first this one, delete. Ouch. Sorry. Oh, no indicator. Acha. Let me go back and draw it again. The problem. We want to say no. I'll go back again. Yeah, so I will bring back the moderator. Let us say switch 1, switch 3. Bring it here. Let us keep it simple, and let us assume that we want to see the moderating effect of this on the likability to customer loyalty, right? So click on connect and click from here to here.
So if I want to remove any construct by cross arrow, the way it's
not necessary. If you like, you can remove it. Otherwise,
how to remove one full construct by clicking on it and pressing delete? It is not removing.
No, you can right click it here and you can delete it.
It is very difficult to remove.
Now you can remove.
Okay, there is a button called delete on the top, which is helping. The right button, extreme right button, delete. If you select that button, then it is helping.
Okay, fine. Anyway, so you can, yeah. Here, yeah, there is a right button here. So
Delete.
let us assume.
After clicking that button, if we click the construct, the whole construct is gone.
Delete. It's not deleting now.
Now you have to click the switch, then the switch will be removed.
No, I have delete. Yeah. After clicking delete and then right clicking and clicking delete here, then it is removed. So anyway, let me bring back the switch. This is our moderating variable. Let me put it here. And let me connect it to the moderating variable. Now, if you remember, if you had worked on this PLS, right? To target variable also. You are able to listen?
Yes, sir.
Yeah, very good. So, but here in this PLSM, you need not connect it to here. The software internally connects it to here and gives you the result, both for the moderating or interaction effect and also for the direct effect from switch to customer loyalty. It will give the result even though it is not showing. In fact, you can connect it and see run the say algorithm and see that there is no change in your interaction effect. So that shows that it is internally it is connecting and giving you the effect. So let us do that. So this is we are trying to do the trying to find out the moderation effect of switch on the paths between likability and customer loyalty. Or in technical term, it moderates the strength between the likability and direction or both between likability to customer loyalty, right? So for doing that, go to calculate and bootstrap. Click on start calculation. Right? So if you see here, let me reduce the zoom so that you can see more. Okay, so can I reduce some more? Yeah. So is it visible?
Yes, sir.
Yeah. So you see here, if you want to see the outer model, you want to see the loadings and p-values, and for inner model, you need to see the p-values and the path coefficients, and highlighting the path. If you want, you can highlight the absolute values, so you can see. But it will confuse more. So let me put off the highlighting off, right? And if you want to, the R square is already given. So it's showing the R square. So this is, so you see here, other things we have already discussed. right? The mediation and the path coefficients for the individual, this one. Now moderation effect is given here and it is significant 0.007 and the value is 0.08. So if you remember in Cohen's D, it was 0.02 was low and 0. Up to 0.02 it is low. From 0.02 to 0.09 or 0.15 it is medium, and above that it may be strong. So based on that you can term this moderation effect as medium or strong. So that is and then more importantly we have to see whether it is significant or not. It is significant 0.007. That means the moderation, our this switch is moderating the path between the relationship between likability and customer loyalty. And if you want to see the reports, go to the final results and you go to the path coefficients. This is what is required. And if you see here, we have to see if you want, these are the path coefficients for each of this one. And we have to see the path coefficient for the interaction effect, right? 0.007 and the mean is 0.000 minus 0.088. That means it is reducing the relation, the strength of the relationship between the likability and the customer loyalty, right? Because it is minus, right? So and this is significant because the p-value is 0.007. More importantly, because we are doing bootstrapping, we have to see the this t statistics 2.691, which is more than 1.96, and then of course we have to see the confidence interval, and we see the value of 0.8 minus 0.088 falls in between this 2.5% confidence level and a 97.5 confidence level. What happened? I'm not able to. Hello? Somebody speaking? Somebody want to ask? Huh?
There is some mistake. I think we have to mute the participant who is by mistake disturbing.
Okay, very good.
Kavita, are you there? Can you help me?
Yeah, so anyway, so this is the interaction effect, this is the moderation. This is the one which gives the moderation. So switch is moderating the effect between likability, independent variable.
Sir, I think they will understand this output later on. You now show them MGA and then we will wind up today's session. They will interpret this on their own.
So this is significant. So
because you have to cover MGA also.
Okay, fine. So let us do the
last 15 minutes now.
So we can save this result. We can save this result. And
who is disturbing Kavita? Please mute him.
We have saved this result.
Sir, done. I have muted. I have muted the participant which was having some issue. You can go ahead, sir. Feel free to go ahead. Kannan sir, are you there with us? Sir, you are not there.
Sir, please unmute yourself.
Yeah, I am calling him.
Yes.
He is by mistake doing.
Yeah, I am unmuted. Fine. Great. So let me share again.
multi-group we can show them, and
Yeah.
then they will interpret the
So-
output on their own.
This is this one. When you have you go to result again, because you have to save the create a new data file where you have to bootstrapping again. We have to run. Right? Sorry, from not bootstrapping, from PLSM. From PLSM, we run it again. Yeah. So we have to create a new data file with these results, and we have to add the MGA in that. Right? So create a data file, and let us say you want to add everything to this data file. Click on create, right? And you can go back. And you can go back again. Say yes. And you see here, there is a new data file, and data has been created, corporate reputation data derived from PLSM. Right? Are you able to see? Oh. Hello. Hello.
Yes, sir.
Yeah. So again, we go to this corporate reputation model, and now we have to select the one which we have created. Corporate reputation from PLS result. Right? So now you see the LV scores have been, this has also been incorporated. And from here, there are a couple of steps which we have to perform. Sorry, let me take the 1 minute. Let me take the data set, which is the earlier one, corporate reputation data set. Here it is there or not? Our service provider. Yeah, it is there. Service provider is there. Anyway, it's there. So we can click
Sir,
on.
but when the constructs are less, we can draw the way this pathway diagram nicely. If the constructs are 8, then it will become difficult to draw this diagram. Am I right, sir?
No, it is already there in your diagram.
No. Suppose we while designing the questionnaire, suppose I am calculating the stress factors.
It doesn't matter. Whatever be the complexity, this PLSM is meant for complex. This one it's only. Otherwise, you can use even SPSS or AMS, etc. One of the reason why you use PLSM is because it takes care of complexity. So it doesn't matter. It may be 100 times more complex. You have to run it and just take the result which you love, which you want. For example, we don't want this moderation or mediation result in for our MGA, but it is there. I don't mind. Let it be there. I will only see the result for MGA. Is that clear? So it doesn't matter.
Yes.
It doesn't matter. Once you have drawn your path diagram, with the same path diagram, you can go on adding or subtracting whatever you want, or you can use the same one. As long as the new calculation doesn't require anything new, you can work on that. Not a problem. Then clear. Or if you like, I can remove the moderator from here. Doesn't matter. If you like, I can remove the moderator.
No. I'm not saying. See, sir, I'm not saying in that way, sir.
Okay, so you can do that. You can do whatever complex with the path diagram. It doesn't matter, right? If you want to do it in part, that's your choice. You can draw only that part, or from the complex path which you have defined, to delete some of the constructs and the paths that you don't want, and then do it for that. It can be done. right? Fine. So for doing MGA, there are few steps are there. I have already shared the literature for MGA. You can see later on. I'm not going to deal with that because I have hardly had 15 minutes. I have to finish it. So calculate, and you have see permutation multi-group analysis. First, you will have to see. Click on this, right? And then you will have to choose the groups between which you want to do the multi-group analysis. Let's say you have service provider, you have got 4 groups. So let's say I want to do it between group 1 and group 2. Now, one by one, you have to do for each one of them, right? Let us say for service provider 1 and 2, and we want to do this MGA and then start calculation. Right? And then it will do it is here. Now we have to see MyCom. You see here under the quality criteria, you have MyCom. Right? Now there are basically 3 steps. First step is that you
So can you repeat how you run this? I want to run again with you.
You want to run again? Okay, fine. Just
So how we did it?
Yeah. You select the data set, corporate
Okay.
reputation data. The previous one itself will do. I
Okay.
don't have to use this one.
Okay.
Newly created. Go to calculate.
Okay.
Click on permutation multi-group analysis.
Okay.
Then it will open the dialog box. Now
Okay.
you have to choose the groups between which you want to do the multi-group analysis. You can do only two. You can take only 2 groups at a time, right?
So let's take 1 and 4.
1 and 4. Fine. 1 and 4. Right? And once you have done that, click on start calculation. Right? It has done the calculation. Then you go to
Okay, got it.
under quality criteria, you have MyCom, right? If
Okay.
you click on this down, there are it shows 3 steps, 3 steps. One is step 2, one is step 3, one is step 3B. Step 2 will take care of 2 things. One is your configural say invariance test and compositional invariance test. Now, configural invariance test means that it will check whether you, in fact, you have to do it. It won't say anything about it. You have to see that whether you have followed the same criteria, same method for both the groups. For example, whether you have got the same questionnaire has been distributed to all of them, whether you have taken the data at the same time and done the same cleaning process, everything. So that is for you to say justify that yes, we have done the same thing, same method has been done. So configural invariance is done. The next step is compositional invariance. Compositional invariance, which we can test it from our results. So therefore, that is what is given in the step 2. So click on this one, step 2. Are you able to see the table? Or should I share again?
Yes,
Yes,
we
sir.
can. Yes, we can see.
I have to share?
No. We can see.
Okay, fine. So you see here, permutation p-value, all these are above 0.05. That means these are all not significant. That is, there is no significant difference in the composition of the groups, right, between the groups. So compositional invariance requirement is established. Had there been any what you call red here, then you can say that only partial invariance is ensured. So otherwise, now here full invariance is assured between within the 2 groups. All the paths, all the constructs are exhibiting full invariance, right? Once you have done that, you have to go to the step 3. Step 3 shows that the requirement is that the mean of both the groups should be same. Equality of means requirement. Now you see it is not so. You have got these two, the 1, 2, 3. These 3 paths are having values less than 0.05. So null hypothesis that there is no difference between the mean. That is rejected. That means the means between the group for all the paths are not the same. Only for these 2 paths is the same. So that means from this table we can say that
So
only
that means we
partial-
cannot run a multi-group analysis between these two.
we are doing the first step of the multi-group analysis. That means we are checking for invariance.
So assumptions of equal variance equal mean
Exactly.
across different group is violated.
Yeah, so it is being violated. So there is no full invariance assured. So there is only partial invariance is there. And then next one is checking for the equality of the variance. Here also, if you see, even though 4 of them are showing say values greater than 0.05, but one value is less than 0.05. So again, this shows the partial, this one. So when you have the partial invariance, so you have to, when you see the result, if you see the path coefficient, once you have done that, you have to see the path coefficient. It won't give you the p-value. That for that you have to do the bootstrap. Anyway, you see the path coefficient. It will give you the values between the original and for the 2 groups, the group differences and the permutation mean difference. This is the difference between these 2 and permutation p values, which are all red. Anyway, we are not concerned with that at this point of time. We will run a bootstrap, but we are concerned with that because these are all red, right? So that means it shows that there is no group difference between the 2. From here itself, you can reject that there is a difference between group 1 and group 4. Anyway, assuming that one of them was green, then in that case, you would have done the bootstrap procedure. You have to go, click on calculate, click on bootstrap multi-group analysis. And again, you select the 2, whichever, these are the 2 groups we are checking. And then click on calculate. And you go to path coefficients. Right? Now, there are various options available.
So can you repeat the step?
Yeah. Go to calculate, bootstrap multi-group analysis. Check the groups which you are trying to compare. Group 1 and group 4.
Okay.
And then click on start calculation.
Can we click multiple?
No, can't. Because only 2 groups you can, you have done only for MyCom for only 1 and 4. So you can do only for these 2. So once you have done that, you go to path coefficient, final result, path coefficient. Now there are 1, 2, 3, 4, 5 options available. Now bootstrap MGA you can use when you have full invariance, right? Full invariance and both this one equality
Mean
of
and variance are met.
are there, then you can use this. Parametric test you can use when the data is normal for all the this one paths. Wells Statterwet test you do when you have means is equal, variance is not equal. If variance is not equal, equality of mean as the variance assumption is contraindicated, but the means is assumption holds good, then you go for Wells Statterwet test. But suppose both of them are one or both are rejected, that is including the means, then you go for bootstrapping results. Right? So in this our case, both are resulted. Then you have to see the, then you do the, what you can do, you have to copy to Excel, then click on Excel and click on this, right? I have to share the Excel file. Are you able to see the Excel file? You are not able to see, no, share the Excel file. Okay. Right? So you are able to see the Excel file? Hello?
Yes, sir.
Yeah. So now we have to see, now you see the means are given for both the groups side by side, right? Original for Pro 1 and Pro 4, right? And then similarly, this one is the bootstrap. We don't need that. We need p-values. So let me remove all this. We have to compare the p-values and see whether the invariance is there or not. So let me delete all this, remove it. And what we will do, we will put the p-value, cut the p-value from here and put near the one for the server Pro 1. Right click, insert. No, sorry. We will insert a column here. Insert before that. Yeah. And we will controls X, control V, and for p-value for this service provider 4, control X and control V. Now you see for both the this one, for both the service providers, we have the this one, we have the path coefficient, path also is there. So now we have to make the invariance test. You have to give the decision about the invariance test. So you can write it here, invariance, whether there is invariance or not. That is whether there is the groups are different or not. Or you can write it as decision. Right? Now, you see here, for competence to CUSA, the p-value is 0.049 and this is also not significant. This is also not significant. Both are not significant. So is there an invariance between the two? Is there any difference? Both are not significant, so there is no difference. So invariance is there. That means no difference is there. The second path, from competence to customer loyalty, p-value here is not significant. Here also not significant. So invariance is there, no difference. Right? The third path, this is significant. This is also significant. So no difference. So invariance is there. Next path, this is significant. This is also significant. So no invariance is there. Then for the next one, likability, here the p-value is not significant. Here it is significant. Are you seeing this?
Yes, sir.
Sir, but in a fourth,
In the fourth one, sorry. In the fourth one, both are significant. So there is no difference. There is no difference.
Everywhere you have written yes, 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 yes.
There is, if both are significant, there is no difference between the group. Both are giving significant result. So there is no
Okay.
difference between the two.
Hmm.
But here
We have to write no or yes.
invariance, yes means no difference. Invariance का मतलब होता है कि कोई difference नहीं. So if yes for invariance means there is no difference. Or if you want to be, because these are the invariance test, that is why we are putting the technical term invariance. Otherwise, make it simple by saying difference. उसमें आप no कर सकते हो, यहाँ जाके yes लिख सकते हो, कोई बात नहीं. लेकिन रिपोर्टिंग में आपको इनवेरियंस ही लिखना बेहतर होगा, है ना, इसलिए ये दिखा रहा हूँ. Anyway, so for this is significant. This is also significant. So invariance is there. For the next one, this is not significant, but this is significant, right? इसलिए this becomes different from the results. So here it will be no. No invariance means there is
Yes.
difference between the groups. Next, देखो आप, both of them are
Both, yes.
not significant, so this becomes yes. And then the last one, ये इसका तो बात ही नहीं है, इसका तो ये तो मॉडरेटर इफेक्ट है, मॉडरेटर इफेक्ट का नहीं देखना, तो वो बात ही नहीं है उसका, इसलिए इसमें कोई बात नहीं, इसका देखना नहीं. तो हम लोग को मतलब इतना we are concerned with only these path. So this group, so what is our conclusion? Yes, the groups are different for this path, not for other paths, right? So the conclusion we have to write after giving this table, after saying that
The last
this
15 minutes.
This is not different, only for this path this is different. So like this you will have to conduct for each permutation of the path between 1 to 2, 1 to 3, 2 to 3, 3 to 4. Okay?
Last 15 minutes to wind up.
So तो ये आपको करना है. So you can save it. I don't want to save it, should I? And then you can so if you want you can
Kavita, take a screenshot.
Yeah, already taken, sir.
for which one? Excel one you take it, yeah, of course. So that by decision say matrix you have to make na. So
You
take
can
the
also
screenshot.
save this Excel file and put it in our folder under your name.
Okay, so let me save it.
Save it and put it in another folder, invariance test Excel,
Okay. Save as
under your folder of Google Drive in our FTP folder for your and others use also.
sorry.
Invariance test.xls. Invariance.
इनवेरियंस mg है, हाँ ठीक है, इसको मैं लोड कर देता हूं. अरे इसमें
वो बाद में लोड करना सर आप.
अच्छा ठीक है, मैं बाद में
टाइम जा रहा है 15 मिनट में.
हाँ ठीक है, बाद में कर दूंगा. ठीक है, तो ये तो इसी तरह से आप क्या कहते हैं नेक्स्ट का भी कर सकते हो, मतलब नेक्स्ट ग्रुप का भी कर सकते हो. एनीवे इफ you want me to repeat I will do that, doesn't matter. Where was it? कहाँ गया ये है ना, right? So
Sir, invariance test shows the relationship of
relationship, you want to find out the difference between the group. So in that
Okay.
you have got two steps. One is with respect to
These are the
finding
assumptions
the
of running multi-group analysis.
yeah. So one
You
is
have to
for
prove that the
finding
groups
out whether there is a
are invariance.
there is a difference, and second is when you want to find out which group is done, which we have done. So like
So
that,
we
I
are
think you can do it for the other groups also, right? So same thing. calculate, go to my permutation, this multi-group analysis, select the groups. Now instead of 1 and 4, let us select for 2 and 3, right? 2 and 3, and then start the calculation. And see in the MyCom this one, and you see only one group is this one. So you can say that in step 2, it is again partial, partial MyCom has been deducted. Then you check the means. Again, there is a partial difference. Equality of mean is not there, and variance it is there. So we can again go to bootstrap, right, and check it and do the same thing. So you can go to the this one, go to the bootstrap analysis, bootstrap MGA, and then between 2 and 3, select 2 and select 3, right, and then click on start computation and see the path coefficient, bootstrap, right, and see the this one. You have to do the draw the, just like I did before. You have to draw the this one table and copy paste all this, and copy paste the remove all those, but except for the original values and the p values, and put it near them and find out whether that is difference, whether it is different in terms of p values in both. So you just give SS, SS, or if it is different, one is significant, other is not significant, you could give it as no, and then say that the group is different from that. So like that you can do for the other combinations also. 1 and 3 and 3 and 4 and 2 and 4. Is that clear? Hello, sir.
Yes, sir. So shall we stop now?
It's your wish, Ritesh sir, whatever you are the boss. Ritesh sir, there?
It is 5:40.
Yeah, so we can stop here. We can stop here, and all the best, right? Shall you close the meeting for today?
Yes, sir. Ritesh sir will decide, I think.
Where is he? Not traceable.
Sir, I will share my data on your Gmail.
Yeah, that you can do. That you can do at your own free time. Not a problem.
Huh. Okay, sir. Thank you. Thank you very much.
Welcome, welcome. Take care. Bye.
Thank you. Great day.
Thank you so much, sir. You're such an excellent personality, and we loved all the sessions. Thank you so much, sir.
Thank you, sir.
Sir, stop recording.
मैं इधर ही हूँ, थोड़ा मैं से गया था।